December 18, Roscosmos dropped a bombshell that contradicts everything they said before. Instead of building a brand new space station from scratch, Russia will now reuse old ISS modules for their future orbital station. These same modules are contaminated with dangerous bacteria and fungi. 65% of samples exceed safety limits. Their own scientists warned against this in 2022, calling the ISS a bacteriological international. So what changed? The answer involves SpaceX's unstoppable rise and one devastating war. Let's dive right in. To understand just how dramatic this reversal is, you need to know what Russia originally planned. The Russian Orbital Station, ROS, was supposed to be their comeback moment. A cutting-edge facility in polar orbit, flying over all of Russia's territory, conducting Arctic research, and studying cosmic radiation near the poles where Earth's magnetic field offers almost no protection. This wasn't just about keeping up with China or the US. This was about reclaiming the prestige they lost when the Soviet Union collapsed. The design specs were genuinely impressive. ROS would operate largely unmanned, controlled remotely from Earth, with periodic crew visits instead of permanent occupation. Robotic arms would handle assembly and maintenance outside the station, drastically reducing dangerous spacewalks. They even planned to deploy and manage satellites directly from orbit, something no space station has ever accomplished. Vladimir Kozhevnikov, the station's chief designer, announced in July 2024 that artificial intelligence would support operations without replacing human decision-making. Russia was positioning itself to leapfrog the ISS entirely. But here's where SpaceX enters the picture. While Russia was drafting these ambitious plans on paper, SpaceX was actually executing theirs in reality. Starship is rapidly becoming operational, making the cost of building new orbital infrastructure plummet. NASA's pivoting toward commercial stations. China's Tiangong is already operational and expanding. Every month that passes, Russia's theoretical advantages shrink while their competitors pull further ahead. How do you compete when you're still planning while others are already building? Then came the first major retreat. In late November, the Russian Academy of Sciences officially recommended abandoning the polar orbit. Instead, ROS would use the same 51.6-degree inclined orbit as the ISS. Deputy Prime Minister Denis Manturov justified this by pointing to potential cooperation with India, which is considering a similar orbit for their future station. Sergei Krikalev, vice president of the Academy, explained that scientists examined radiation exposure, scientific goals, and long-term mission plans. The polar orbit would have exposed crews to dangerously high radiation levels, which is exactly why ROS was designed to be mostly unmanned in the first place. This orbit change wasn't just about science, though. Oleg Orlov admitted that geopolitical factors and international partnerships played a major role. Translation: Russia realized they couldn't afford to go it alone anymore. They need partners, and those partners aren't interested in polar orbits. But if switching orbits was retreat number one, what came next was a full surrender. On December 18th, Orlov revealed the real plan. The Russian orbital station would essentially be the Russian segment of the ISS itself. Once the US deorbits their portion around 2030 to 2031, Russia would simply separate their modules and continue operating them independently. Equipment that's already been in space for decades would form the foundation of Russia's new station. The station that was supposed to showcase Russia's technological rebirth would actually be built from hand-me-downs. Why such a dramatic reversal? The numbers tell a brutal story. Russia's original estimate put ROS at $6.7 billion, almost certainly lowballing the real cost. For context, the US is spending $935 million on just one module for the Gateway Station using proven technology. China's Tiangong cost over $8 billion. Now look at Russia's entire civilian space budget for 2024. $1.59 billion. That has to cover ISS operations, ROS development, and all other science missions. The math simply doesn't work. The workforce crisis makes it even worse. Roscosmos employs around 180,000 people, but productivity averages just $27,000 per worker per year. That's barely enough to maintain existing operations, let alone construct an entirely new orbital facility. The war in Ukraine has drained skilled workers, manufacturing capacity, and funding from almost every sector of Russia's economy. Roscosmos is trying to keep Russia's human spaceflight program alive while operating on fumes. Reusing ISS modules isn't just cost-effective, it might be the only option that keeps Russian cosmonauts in orbit at all. But here's where it gets genuinely disturbing. Back in 2022, Oleg Orlov, the same person now endorsing this plan, explained in detail why old ISS modules absolutely should not be used for a new station. The ISS is what he called a bacteriological international, contaminated with dangerous microorganisms brought aboard by dozens of cosmonauts from around the world. In roughly 65% of analyzed samples from recent expeditions, microorganisms exceeded safety limits. These aren't harmless bacteria. They can cause allergic reactions, soft tissue diseases, and upper respiratory infections, especially in people with weakened immune systems. And it's not just bacteria. Fungi pose an even more insidious threat. These biodegrading organisms physically damage materials and equipment. On the Mir space station, they cause failures in communication systems. Orlov's warning was clear and unambiguous. Bringing contaminated modules into a new station would create endless problems for future crews. So what changed in 3 years? Did the bacteria suddenly become less dangerous? Did the fungi stop eating through equipment? Obviously not. What changed was Russia's ability to afford alternatives. They're now banking on cosmonauts spending significant time fighting microorganisms instead of conducting actual research. The maintenance burden tells an equally grim story. During ISS expeditions 63 and 2020, crew members spent 25.3% of their total time, nearly 580 hours, just repairing and restoring the Russian segment. By late 2023, Vladimir Solovyov from RSC Energia reported that cosmonauts were spending up to 50% of their useful time on station repairs. Half their time. Not doing science, not running experiments, but keeping aging systems from failing. Now Russia plans to make these deteriorating modules the core of their future space station. Does that sound like a long-term solution? Of course, not all Russian modules are ancient. Nauka and Prichal both launched in 2021, giving them potentially decades of operational life remaining. It's not entirely unreasonable to keep these newer modules as a foundation, similar to how Axiom is planning to attach commercial modules to the ISS before eventually separating. This approach would let Russia maintain continuity of existing experiments and equipment after the ISS retires. The real questions are far more complex. Can Russia replace aging modules like Zarya and Zvezda in time? Can they get their segment into a condition where it can safely operate independently? And most critically, can the Russian segment even function without the American side anymore? Here's something most people don't realize. Everything on the ISS is deeply integrated across national boundaries. Reports indicate that an auxiliary computer sent up to replace aging Russian systems is actually located in the US segment and cannot be moved. Power systems, life support, navigation, they're all interconnected. Separating the Russian segment isn't like unplugging a laptop. It's like trying to remove half the organs from a body and expecting both halves to survive. Then there's that infamous leak in the Zvezda module. Honestly, the leak itself isn't catastrophic. It can be completely stopped by closing the vestibule door. The reason they keep the door open is pure convenience. Opening and closing it every time they need to access a Progress spacecraft is tedious. The media has massively overhyped this issue, but the leak is symptomatic of a larger problem. The Russian segment is aging, and patchwork fixes are becoming the norm rather than the exception. The geopolitical reality is even harsher. International cooperation between Russia and its ISS partners has collapsed. Relations are at an all-time low, and there's no indication they'll improve anytime soon. Continued Russian operations on the ISS become increasingly problematic when trust has evaporated. Building a separate station, even one cobbled together from old parts, gives Russia autonomy they desperately. Starship is on track to reduce launch costs by another order of magnitude. Commercial stations like Axiom and Orbital Reef are moving from concept to reality. China's Tiangong is operational and expanding. India expects to have their station by 2030. Meanwhile, Russia is planning to separate aging modules from a 30-year-old station and call it new infrastructure. The contrast couldn't be starker. While SpaceX catches rockets with giant mechanical arms and plans cities on Mars, Russia is trying to sterilize decades-old modules contaminated with bacteria. This isn't just a technical challenge. It's a symbol of how far Russia has fallen in the space race they once dominated. So here's what this really means. Russia claims they're building the future of their space program, but they're actually salvaging the past. While SpaceX revolutionizes orbital access with reusable rockets and plans interplanetary missions, Russia is planning to operate modules contaminated with bacteria that their own scientists condemned 3 years ago. The irony is almost painful. Roscosmos says this approach saves money and maintains their human spaceflight capability. That's technically true. But at what cost? Cosmonauts will spend half their time repairing aging systems instead of pushing scientific boundaries. They'll battle dangerous microorganisms instead of unlocking space's mysteries. This isn't innovation, it's survival mode. The brutal reality is that economic sanctions and the war in Ukraine have forced Russia's hand. With a civilian space budget of just $1.59 billion covering all operations, they simply cannot afford to build new. SpaceX's efficiency and China's Tiangong success have made that gap impossible to ignore. Russia once put the first human in space, built Mir, and dominated orbital operations for decades. Now they're reduced to recycling contaminated modules just to stay relevant. Will it work? Maybe. Russia has pulled off impressive engineering feats with limited resources before, but one thing is certain. The new space race has left them behind, and this decision proves it. What's your take on Russia's strategy? Drop your thoughts in the comments below. If you want to stay updated on the real story behind space developments, hit that subscribe button for Space Update 24 hours and turn on notifications. Like and share this video to help others understand what's really happening in orbit. Thanks for watching.